Okay, so this is our lecture on arranging tables. And in case you're wondering about the little infographic here with James Hetfield, Metallica had a song called The View where James Hetfield exclaimed that he was the table. It's kind of a horrible cut off a horrible album, the Lulu album, in case you need to know. But do yourself a favor and don't listen to it. We're going to talk about tables and uh, terms of computer visualization here instead. And I think that'll be a more interesting topic. So the big picture shows us the different ways to arrange tables. And there are really four here encoding design choices for how to arrange tabular data in terms of the space it takes up. One way to do that is to express values. The other three are to separate, order, and align different regions. The spatial orientation of the axes can be rectilinear, parallel, or even radial. Spatial layouts can be dense or they can be space filling. So really it boils down to four different design choices that you see here. So we can arrange things in tables by keys or values. And this is the most crucial visual encoding choice for tables because the use of the space dominates the user's mental model of the data set. So if we're thinking about arranging things by keys, a key is an independent attribute that can be used as a unique index to look up items in a table. The value is a dependent attribute, so it depends upon the value of the key. And keys can be categorical or ordinal, while values can really be of any different type, even up to the ratio level of measurement. They're not limited to the categorical or ordinal values. In terms of expressing quantitative values, we can use space to express the quantitative attributes. And this picture here is from the tool called Gapminder. If you haven't played with Gapminder, I encourage you to do so. It's a really nifty tool for seeing how you can visualize different types of data on multiple dimensions. And this is a scatter plot where we have two quantitative value variables, both the vertical and the horizontal spatial positions. So here we have the life expectancy along with infant mortality. And so you can see there's a kind of a strong correlation between those two. But you could also plot income and life expectancy for countries. And I think that's the default one in Gapminder. The other thing that you see is the size of the bubble indicates the size of the country that is being encoded, and the color indicates the region for that country, so which part of the world it's in. So Gapminder does a really good job of expressing multiple variables all at once, and definitely take a look at that. We can also use tables to separate, order, and align categorical regions. And here we have two different elements. The first one shows the average weight in pounds for different categories of critters. There's capybaras, cats, and wombats. And I think these are encoded alphabetically in the first one. In the second one, they're encoded based on increasing weight. So, cat is the smallest in terms of weight, then wombat, and then capybara. And capybara should definitely be number one on this list because they're kind of a cool animal. I wish we had capybaras instead of mongoose, but we get what we get here in Hawaii. Another way to do tabular data is with stacked bar charts, and these can be used to express more complex glyphs for each bar, where multiple subbars are stacked vertically. And in typography, a GIF is an elemental symbol with an agreed set of symbols intending to represent a readable character for the purposes of writing. So this is a stacked bar chart used to inspect information from a computer memory profile. The keys used to distribute the composite bars along the x-axis in combination of processor and the procedure. And we use this key to stack and color the glyph subcomponents based on the type of cache miss. The height of each bar encodes all the cache misses for each processor procedure combination. Another cool way to do this is through the use of steam graphs. and they can also be used to represent multidimensional tables. And you can find out more about those on pages 153 to 154 of the text. Another way of encoding tabular data is dot and line charts. Dot charts encode one quantitative attribute using spatial position against another one using point marks, and rather than lines on the bar chart. The line chart, we typically can do the same thing, but we show runnings between the points. If you go with if you have discrete items, you want to go with dots. If you have something that you believe can be interpolated, or you can extrapolate, a relationship between the current one and the next one, then you can go ahead and use the lines. But if there's, no relationship, like you don't think there's a time component, and they're, completely discrete, then you would go with the dot version. You can also do matrix alignment with two keys, and one key is distributed along the rows and the other is distributed along the columns. And then you can use color to distinguish between them. So these look like they're different parts of different files. This is limited to between 3 and 11 bins for categorical attributes, and that's due to our limited perception of color. Radial layouts are also popular, where you can distribute items around a circle. So here we have A and B. A is the data expressed as a bar chart, and B is laid out radially, the same data in the same bar chart. But our angle channel, in terms of interpreting information, is less accurately perceived than rectilinear position. So it's a little bit more difficult to tell the varying magnitudes of these items in B. The other cool thing that you get with the angle channel is you can use it to depict cyclical data. Pie charts, this is the most commonly used radial statistical graphic, and we've explored some of the difficulties with pie charts. They have limited amount of data that can be encoded and limited number of bins. But you can also have polar pie charts, which are called coxcomb plots, that have equal angular representations of the different data. Some synonyms for polar area chart are rose plot and coxcomb plot, and these were first popularized by Florence Nightingale in the 19th century. And let's take a look at that. Historically speaking, in 1858, Nightingale wrote her notes on matters affecting the health, efficiency, and hospital administration of the British Army. And she created a remarkable and original graphical display just to show us just what really gone on in the war. It was a polar area diagram that showed how people had died during the period from July 1854 through the end of the following year. And the graph is a lesson in the engineer on how to present data, not only so that it's clear to the reader, but to reveal the big picture as well. So it's like a pie chart, and it's cut into 12 equal angles. The slices advance in the clockwise direction. Each shows what happened in 1 month of 1 year. The outward reach of each slice shows how many deaths occurred in that month. And then what we see short slices in April, May, and June after the troops land in Crimea. The slices begin reaching far outward in the radial direction. There's more. Each slice has 3 sections, one for deaths from wounds in battle, one's for other causes, and one for disease. Except for the bloodiest month of the siege of Sevastopol, battle deaths take up very little portion of each slice. Even the awful charge of the Light Brigade yielded only a modest fraction of the total deaths in that month. Once you see Nightingale's graph, the terrible picture is clear. The Russians were a minor enemy. The real enemies were cholera, typhus, and dysentery. Once the military looked at that eloquent graph, the modern army hospital system was inevitable. And, sadly, war and disease have helped develop a lot of our statistical techniques. The Poisson distribution in statistics was used to model deaths by horse kicks in the Prussian army, and Voronoi diagrams found a home in tracking the cholera outbreak in London back in the 1850s. So, a lot of the innovation has occurred through war, famine, pestilence, and death, sadly. The other tool that we can use for, or another type of visualization is dense layout that we can use for tabular data. And these use small and densely packed marks to provide an overview of as many items as possible. The color and position channels take priority here in these layouts. And what we have pictured here are varying lines of source codes and the execution of the tests that were associated with them. And this particular tool is called Tarantula. It shows the dense overview of source code with lines colored by the execution status from the software suite. And I believe red here is code that is less executed, whereas green has been well tested and yellow is somewhere in the middle. Anyway, thanks so much for watching.